Good day. In this video, we're going to look at a fundamental counting principle question for grade 12. This question is from the Department of Basic Education, November 2016, paper 1. The question reads, the digits 1 to 7 are used to create a 4-digit code to enter a locked room. How many different codes are possible if the digits may not be repeated and the code must be an even number and it must be bigger than 5,000? In all probability problems, it is good to plan your answer. Firstly, they said the digits 1 to 7 are used. So I write them down. 1, 2, 3, 4, 5, 6, and 7 is used. So the number of data pieces in my sample space is 7. We're not using the numbers 0, 8, and 9. Next, they said it's a 4-digit code. So I put down 4 lines, 1 for each digit. Next, they said it should be an even number. For any number to be an even number, the last digit must be 0, 2, 4, 6, or 8. In other words, 0 or an even number. So this digit here can only be a 2, a 4, or a 6 because that's all we have available. Next, they said the number should be bigger than 5,000. So this line will represent a digit that will determine that part. So on this line, we can have a 5, a 6, or a 7. Please stop the video and get your brain around this information. Now, with all these facts in mind, we can work out our answer. First, we're going to start with the codes that's going to start with a 5 here. I'm forcing a 5 onto this line, so there's one of the digits I can use here. Then, because it's an even code, I need here to use either 2, 4, or 6. So there's 3 possible numbers I can use here. At this stage, we've used one of the digits here and one of the digits here. So there's 5 left that I can use on this line. Then I've used another one, so far I've used 3 of my 7 digits. Then there's 4 I can use over there. Using my counting principles, I times them, and I can have 60 codes that will start with a 5. Now I just closed this part of my answer. Now we're going to go for the code that's going to start with a 6. So we force a 6 onto this line. So we used one digit already. Now I want this code to be an even number. So at the back, I can choose 2, 4, or 6. But I've already used the 6, so I can't use him again. They said different codes. Therefore, the 6 falls away, and I have 2 choices on this line. So by now, I've used 2 of my numbers from the 1 to 7. So on this line, I have 5 left that I may use. Then I have 4 of my 7 digits available to use on that line. Using my counting principles, I multiply them and I get 40 codes that will start with a 6. Please stop the video and get your brain around these codes that all started with a 6. Next, we're going to go for the codes that starts with a 7. So we're going to force a 7 onto this line. So there is one digit available for this line. Because it has to be an even number, here I can use a 2, a 4, or a 6. So there's 3 possible digits I can use over here. Then, because I've used 2 of my 7 digits already, how much is available for this line? Yes, there's 5 digits available for that line. And then there will be 4 available for that line. Then we multiply them together and we get 60 codes will all start with a 7. So now I just closed everything for a moment. And at the end, we add all these numbers and we get 160 possible codes that will work. So there will be 160 different codes that will be even numbers, that will be bigger than 5,000, and they will be all different that will work on this locked room. Please stop the video and get your brain around how this was done, what it means, and see this technique that we used. Please indicate whether you liked or disliked this video and subscribe to the channel. Enjoy the fundamental counting principle.